Okay, in previous chapter, we introduced two critical important components found in electronic control system. Here, we have discussed about the overview fundamentals of automotive and the basic of electronic control engine. So we come to know how engine plays important role and what all the survey have to made the major components and the typical engine block and some concept about ignition systems, spark plug, and uh, important parameters where um, the space included in diesel engine or a petrol engine. And after that, we are discuss about the basic of electronic engine control. There, we discuss about some general terms and effect of fuel, air fuel ratio, and the spark timing and easier performance control strategy and engine fuel control system and analysis of intake. The main port pressure that is two petrol, two pipes is been embedded, and at last 15 everything that. That's all related to model. And if you come with the model two, so we are going to main focus with the automotive sensor and automotive engine control actuators. So here we'll discuss in depth about the application of sensor variable to be measured and airflow rate sensor and strain gauge map, then engine crank angular position sensors. So they're all related to the sensor only. Okay, exhaust gas, oxygen, O2 and EGO. Okay, so after that we'll see the automotive engine control actuators. So there we'll be going to see a focus with the solenoid and file injection, ACR actuators and all. Okay. So let me discuss some in depth about the sensors. That is the module two. The module two tells about module two tells about sensors and actuators. Okay. So here we'll discuss about in depth about automotive control systems, applications, then total angle sensor, then temperature sensor, then coolant sensor, then knock sensor, then variable valve timing, Then after we'll discuss about electronic motor actuators, then stepper motor and ignition system. Stepper motor and ignition system. So, in previous chapter, we introduced two critical important components found in any electronic control system, that is the sensors and actuators. Okay, and this chapter explains operation about the sensor and actuators, which is used throughout the modern car, and the special emphasis or existing players on sensors and actuators used for a powertrain, for an engine to be a transmission, and let me discuss the automotive control system application for sensor. So any control system application, the sensor and actuators are many cases the critical components for determining the system performance, and this is especially true for automotive control system applications. And nowadays, the availability of proprietary sensors and actuators decides the design of the control system, and the sensor and actuators that are variable to control design, not always with designer ones, because may not be a commercial available for acceptance. Okay, in this chapter, we'll discuss the position of the total plate sensed by the total position. We call it as TPS, and directly regulates the airflow to the engine. Okay, so this is the model to contain, where we're going to discuss about the sensor, a digital engine crank regulation, then we call it as CKP, and Hall effect position sensors. Main code is called as MAP. Then ECT, that is engine control temperature, and clock sensor, actuators, then fuel injector, evaporating emission systems. Okay, if we discuss with the type of automotive sensors, we have rain sensor, the fuel level, parking sensor, speedometer or technometer or odometer, or speed, wheel speed, anti-theft sensor, GPS radar sensor, and accelerometer, oxygen sensor, water coolant temperature, oil sensors, and indoor-outdoor temperature sensors. These multiple temperatures we are going to make a card in car to be modern, or looking with the smart, like smart intelligence. Okay, so if you try to focus with this, we have multiple features which we included to form the car to be intelligent and smart. Okay, so the automotive sensors and actuators, where the automotive manufacturers are continuously increasing use of electronic system that improves the performance, safety, and passenger comfort. So we are going to consider this to be as main credential, where the sensors and actuators integrated with automotive control to help to optimize vehicle performance while improving the reliability and reliability. Okay, if we see the variable to be measured, the superset of variables sensed in engine controls includes the following, that is MAF, that is called mass airflow, then exhaust gas, the total position, tank angular position, that is RPM, the temperature sensor, intake air temperature map, differential exhaust pressure, vehicle speed, on brake off, wide operation pedal, and closed operation. This is the additional measurements we are going to see. So comparing with discussing with the block diagram of electronic